Welcome everyone to today's demo called BEEST Suite. My name is Dmitry and I'll be presenting the demo today. The topic of this demo is not BEEST itself, but all the other programs included with it in the BEEST Suite. As of October 2017, we are actually including 10 other programs that are installed on your computer when you install BEEST. And what we're going to be talking about today is what all those other programs are, what do they do, and when would you use them, or what kind of modeling scenarios would you use them for. And for the purposes of today's demo, I've grouped other programs into three categories: programs for meteorological data processing, model setup, and then working with output files. And we'll go through all 10 programs one by one, and I'll discuss them. And I have slides for all but the last two, so I'll just show the last two programs on the screen at the end of this webinar. All right, second, besides BEEST, which is our main program for second model runs and actually running the models and viewing the output files, we have all these other programs, and I wanted to discuss today what they are used for. Well, starting with our meteorological data programs, the first one is AER-MET. We added this program to BEEST Suite back in 2004, and what it does is that it processes raw meteorological data files for you and creates a meteorological data file that's used by the AirMod model. And you can have the service operator and/or on-site stations in your AirMod run. In your AirMod program. The on-site is optional, and so is the hourly wind data that AirMod provides to you, which I'll discuss in a little bit. So you would use AirMod if you need to create a meteorological data file for AirMod. Sometimes you don't need to do that because sometimes state regulatory agencies or state modeling agencies provide these files for you. In that case, there's no need to run AirMod. But if you are creating meteorological data files by yourself, and especially if you're using on-site data, that's when you would use this AER-MET program to create your own metadata files. And this program actually includes a small modeling exercise where you run AirMET for surface and upper air data. To view the instructions for how to do that, you can open this test case instructions document in our program and view those tests for running AirMET. We have also recorded a webinar in the past on how to use this program that you can view. Also, again, the AirMET program is used whenever you are creating your own metadata files for AirMod, and when you don't have ones provided to you already by somebody else. Our next program, which is also for meteorological data, is called AER-Minute, and that's used in conjunction with AirMET. What it does is it processes just wind data supplied by I think it's NOAA in the United States, and after it processes wind data files, it creates an hourly wind data file for AirMET. And what that allows you to do is to fill in any gaps where the data in the surface data set is missing in AirMET. And if you do use AirMinute, that will reduce the number of hours with missing data that you have after you run AirMET. So this program can just give you a more complete data set for when you run AirMET. And we also have a webinar on how to run this program that you can view. And that's posted on our website as well as the other webinars mentioned today. And finally, for this group of programs, we have a program called Windows, which we added just this year to BEEST Suite. That allows us to display Windows for your metadata files, either for 1 year of data or several years. And with this program, you can just visualize what your metadata set looks like. And I'll go ahead and show that now. So this just displays your not all metadata, but specifically WinData graphically. And we also have a tutorial within the program that gives you more information. So let me go ahead and open up this program and select one of our metadata files. This file is for the year 2012. When I do that, the program opens the file for you and then displays your wind speeds from which the wind is blowing and how frequently those wind speeds occur. So for example, this one from the northwest occurs quite a lot, or from the north-northwest occurs quite a lot in this metadata file. And you can just see the patterns in your wind speeds and directions with this program. And that can just be done to review your metadata files, but this is not a mandatory step in every modeling exercise. This is an optional step that you can do. Using this program is optional, as opposed to using AirMet or a file that's provided to you. You will always need to have a Met file if you're on AirMod. But using this program, the Windows program, to review it is optional. And again, we have a tutorial included in the program that gives you more information. All right, so our next set of programs are for setting up a model in BEEST. They help set a model in BEEST and then running models. And in BEEST, we actually added the a feature back in 2010 that allows you to take what you have entered into BEEST and export that to Google Earth. What that allows you to do is to see how close what you have in the model setup is to what's actually on the ground, or to the stores and buildings that are actually built, or that are actually part of your model site. We have improved that feature several times since then, and then in 2012 we've added a program called Import KML that goes in the opposite direction. With this program, you can draw objects in Google Earth and then take them back into BEEST or import them back into BEEST. And what that allows you to do is to possibly draw all of your model objects in Google Earth and then save them, and then import them into BEEST in one step, which will allow you to have those sources and buildings quickly to BEEST. So this is just to speed up your model setup in BEEST. And we have both a user manual for import KML and a webinar that we've recorded for how to use this one, or how to use this program. But again, after you use this program, you will have added objects to BEEST, and that's part of your modeling setup. Next, we have something called the BPAP tool. And one part of the modeling process is that if you have sources and if you have stacks and buildings in the same model, you would typically want to run the BPAP prime model or BPAP model to calculate the downward parameters which are how your buildings influence the flow of pollutants from your stacks as the pollutants are emitted. So again, if you have stacks and buildings in the same model, you would almost always want to run this BPAP prime program to calculate the damage parameters. And what sometimes happens is that if you have a large number of sources or buildings, we usually only have hundreds of them, the BPAP prime program can take up more memory than your computer has. This used to be more of a problem about 10 to 5 years ago. It's less common now. But what this tool can help you do is split up a large model run so that it can be run on your computer. What this tool does is to create several smaller runs for you, run them, and then create one output file that's for the whole that's for the whole input file. And we have a help file within our program that gives you more information on how exactly to do that. Again, this used to be more a problem when computers were less powerful about 10 to 5 years ago. It's less common now, but it's less common now. But we still have this program within BEEST, so that you can use it if you need it. And finally, we have the scheduler program, which we've had, I think, since the early 2000s. And once you have completed your model setup in BEEST, you'll need to run the model. You can do that directly from BEEST if you have just one model to run. But if you have multiple models, then you would usually create batch files for them. And the scheduler program assists you with that process, with the process of creating batch files for all the models. And then also, if you have a batch file with many model runs that you want to split up and run in parallel on a multi-processor computer, you can do that as well here with this program. Let me go ahead and show you how scheduler works. All right, so in this example, we have a batch delivery editing that has just one model run in it. I can go and say save now. Give it a name, and then when I go to the the schedule tab, I can either start the run right away, or tell it to run a little bit later. And let's say if I say start now, then it'll run right away. Also, while doing that, back in the setup tab, if I had multiple runs in the same batch file, I could say split here and tell it to create up to 4 batch files for me that would each have one run in them, and then run them in parallel. So this program is used more when you have multiple model runs to start, not just one. It helps you start all of them at the same time. And again, I just show you the model runs can be run either immediately or at a later time. And we also have a help file within this program that gives you more information. And finally we get to the problems that you use after you have run a model, such as the AirMon model. What do you do with an output file? Well, there are actually a couple of things that you can do. Typically after you have run a model, in BEEST you have two buttons here. One is for this USF viewer program that I'm about to discuss. One is to just display your output file within BEEST, and that will just display all of your receptors and all of the concentrations at those receptors that you have modeled. And you can zoom in here and see where the maximum value lies. It's right here in this modeling file. So that's the graphical view in BEEST. But there's also this textual view, which is this USF viewer program. And this displays just a summary of the highest concentration for each of your pollutants and your averaging periods that you've selected in the model setup process. And you would use the USF here to display concentration values. And if I click on this button, what that will do is you will open up the summary file and display just the highest concentration for each. Actually, it's each source group and averaging period that you have. And if I click the right to grid button, that will be displayed a little bit easier. So you have your pollutant, the averaging period, and then the first highest value. And this is the same 328 that BEEST displays, the same value that BEEST displays. And this program it won't display the values at all receptors, just the highest one that you've modeled. It'll display that for you. And I would typically open the USF viewer after every model run just to see the summary of your modeling results. And the summary can also be exported to Excel just by clicking this copy grid to clipboard, or saying edit and copy with headings. You can copy and paste to Excel to create a summary of your modeling results in Excel. And also for your stuff, we also have a user manual if you want to see more details. Okay, so USF viewer is typically used to display a summary of your concentrations. We also have another program called ARY viewer. And what that does is display a summary of your exceedances. Now, what an exceedance is it's when a concentration value is higher than a certain limit that you define in BEEST. So let's say for SF2, which is in the model of in BEEST, let's say for SF2, if you want to see how many times the concentration exceeds, let's say, a value of 130 micrograms, you can tell BEEST to give you that information, and then run a helper program called Array2 in BEEST to calculate how many times this value was exceeded at each receptor in your model. And what ARY viewer then does is it just displays the number of times that your limit was exceeded at each receptor. So again, this isn't the concentration. This program tells you how many times the concentrations were higher than a certain limit that you've set. And for more information, we have a tutorial on how to run this program and how to use ARY viewer. And you can see this tutorial in our BEEST software. It's called Calculating and Displaying Exceedances. And that goes into more details on on how that works. And finally, before I conclude this presentation, we actually have two other programs called Max DCONT Viewer and Split GIF. Now, Max DCONT Viewer is only used if you're modeling 1 hour SO2, 1 hour NO2, and 24-hour PM 2.5. Unlike USF Viewer and ARI Viewer, this program is not used with all pollutants. It's just these three in the 1 hour SO2, 1 hour NO2, and 24-hour PM 2.5. And what it allows you to do is, if you've set up multiple source scripts in BEEST, or for example, you have emissions from all sources inside and outside your facility, and then another source script would be everything inside your facility. Max DCONT Viewer allows you to see out of the total concentrations that were created by all the sources, how much of those come from how much of those concentrations come from your facility specifically, or maybe even some sources within your facility. So that allows it to see how much your facility contributes to an exceedance or contributes to the higher concentration. And in this program is used after you have run AirMod and after you have a file with outputs and with output concentrations. Let me see if I have a file here. Oh, no, I actually do have an example output file. What this shows to me is that I have a model run with a few receptors here. And let's say I'm modeling, I think this is a SO2. If I'm looking at the fourth highest value for SO2, I can select various source scripts here and see how much of the concentration comes from those source scripts. Let's say if I select the all source script, you see the highest value here is 595 micrograms. And then I can go ahead and select other source scripts, and that's all variable displayed at the top, and then their individual contributions will be displayed at the bottom. And for more information on Max DCONT, we have a webinar on how to use this program, and we also have a manual within the program itself that explains how to use it. So for more details on how to run this Max DCONT and whenever that's used, click on Help and Tutorial within the program, and that will display tutorial for you. And finally, we have the Split GIF program, and that is used with BEEST as well. Now, typically, when you're on the ML model in BEEST and you get your output file, that output file typically contains multiple sets of results. So in this case, we have a annual results, 3 hour concentrations, and 24-hour concentrations. So those three sets of results are placed all in the same file. What the Split GIF program does is it takes that output file and creates separate output files for each set of results for you. So if you only want your output files to have just one set of values in it, and create three files or multiple files out of this one split JF will do that for you. And this program has a user manual that you can take a look at to see exactly how that's done. All right, thank you very much for attending the webinar. We will now stop the recording and take questions from the audience.